All right, so our topic for today is, sabi ni Sir Jobs is, ano nga 'no, one of the interesting, topic here in Asia Open RAN because, this is more on the foundations of the 5G mobile system or a 5G mobile network. So what we will be discussing today are all about the foundations of this topic. Okay, hold on lang, ayan. Okay. So we'll be discussing about the what is 5G, okay? Um ano yung definition of 5G. Okay, so what are the different what is massive MIMO, okay? So yung mga technologies behind 5G. We also discuss some mobility report coming from Ericsson mobility report. Okay, so discuss some 5G use cases, ano yung mga 5G targets and footprints. Okay, 5G footprints, and then basic architecture ng 5G and how we usually implement this here in the Philippines and in other networks from other countries. And yep, yung mga other supporting technologies no, about 5G. Okay. So let's start our topic with the Ericsson Mobility Report. So that was released last November 2023. So this is the mobile subscription forecast no, coming from Ericsson. So based from this, the 5G subscriptions are forecasted to reach 1.6 billion by the end of 2023. Yan. So ganito karami na no, yung subscription all around the world. And if you will see here, yung number of mobile subscription from 2018 up to 2029, yung forecast, aabot yan ng 9.2 billion. Okay, so medyo malaki no, yung ano niyan. So it will exceed the 5.3 billion in 2029, yung 5G. Pagka tinignan natin yung 5G dito, you can see it will exceed to 5.3 billion in 2029. And 5G continues to increase its share of the overall smartphone market. And 5G devices capable of supporting new network functionalities will enable also services beyond mobile broadband. And on the other hand, nakita nyo rin yung ating LTE, although slowly declining but still a huge chunk would still be forecasted until 2029. And yung ibang mga technologies like GSM and WCDMA are slowly declining, but both of them will still be there. Okay? So ito yung ating forecast, no? So one of the main reasons why we are putting this in the forefront of our discussion, the 5G. Because if you're learning 5G right now, you still have 6 years or 5 years or more than 10 years no, to deal with this kind of technology. Okay? So let's start our discussion. What is 5G? Okay, so 5G is, 5G is a fifth generation of mobile communications that uses new radio access called NR or new radio. Okay, and this is connected to a new 5G core network called the 5GCN. Okay, so this one. And it will be focusing on three distinctive classes of use cases. Ano yung mga use cases na yan? So we have the enhanced mobile broadband, massive machine type communications or the MMTC, and the ultra reliable and low latency communications. So when we talk about EMBB, okay, the enhanced mobile broadband, ang ibig sabihin lang yan is high data rate. So mabilis na throughput and high traffic volumes. So sa mga initial testings na ginawa dito sa Pilipinas sa ibang bansa, umabot tayo ng 1 gigabit per second. So that is equivalent to 1,000 Mbps per second. So ganun kabilis no yung 5G in terms of EMBB. So pag sinabi ng enhanced mobile broadband. And then we also have this so-called the MMTC, the massive machine type communications, meaning massive number of devices, no? Maraming klase ng devices, no? Up to 1 million devices per square kilometer ang pwede nating i-connect sa ating 5G system. So this is also called massive IoT or Internet of Things. Yan. And the next and the last use case in the major use cases is the URLLC, or the ultra reliable and low latency communications. Okay? So when we say ultra reliable, so that includes high reliability and availability up to 99.9999%. Okay? So ganun ka reliable yung network natin. And when we say low latency communications, it connotes to very low latency, no? Instant response ng network. So if you're familiar with the testings no ng ping test, yan. Or naglalaro kayo ng mga Mobile Legends, so yung paglalag ng inyong gaming experience will not be possible anymore, no, kasi nga mas mabilis yung ating latency or response ng network. So sa target ng 3GPP, it would go up to 1 millisecond. So ganun kabilis yung response, no. Okay, so ito yung ating simple architecture ng 5G, and these are the three distinctive classes of use cases. So EMBB, MMTC, and URLLC. Okay? I-adjust ko yung camera ko. Yan. Okay. Now let's move on sa um, sa mga use cases, no. So EMBB, mga applications naman within the use cases. So the 5G is the latest iteration of the mobile network that we use to connect our smartphones and other devices to the internet. So it promises to be faster and more reliable and more efficient than previous generations such as 4G. So with the potential to support a wide range of new applications and services. So overall, the three use cases that I mentioned previously, the enhanced mobile broadband, okay, the ultra reliable and low latency communications, and the massive machine type communications, demonstrate the diverse range of applications that 5G can support. So 5G networks continue to be deployed around the world, and we expect to see even more exciting and innovative applications that take advantage of this advanced wireless technology. Although I'm sure you have seen the the Apple Vision Pro, but the Apple Vision Pro is not connected to cellular when I check the specification. Connected lang siya sa Wi-Fi or Bluetooth. So maybe in the near future, those augmented reality glasses will also be connected, no, sa ating wireless or cellular network to have a more immersive experience, no, pagdating sa mga subscribers. Okay? So nakikita niyo yung iba't ibang mga applications ng 5G, no, based sa kanilang use cases. And I will discuss it further, no, in the next slides. And the next is the 5G performance targets. So these are the 5G performance targets. So makikita nyo dito, ito yung ating EMBB, the enhanced mobile broadband. Okay? We have the massive machine type communications and the ultra reliable and low latency communication. And then you will see a regular octagon inside this use cases. So ito yung target ng IMT 2020. Okay? So when you say IMT 2020, ito yung target ng 5G. And then inside, meron kayong makikitang irregular octagon. So this was the target of the IMT Advanced. So IMT Advanced is also known as LTE, no? Ito yung LTE target. So if we compare the target of LTE and 5G, so makita natin ito, for example, in the peak data rate of 1 gigabit per second sa LTE, for 5G, it will be 20 gigabit per second. So that is 20 times better than LTE. And when it comes to connections or throughput anywhere, whenever needed, 10 Mbps kay LTE and 100 Mbps naman kay 5G. Spectrum efficiency, it would be 3 times more than the LTE. And in terms of mobility, you can see the mobility comes from 400 kilometers per hour up to 500 kilometers per hour, no, kay 5G. And in terms of latency, from 10 millisecond, target ni LTE, magiging 1 millisecond. Yan. And in terms of connectivity, it would be from 100,000 devices per square kilometer kay LTE up to 1 million devices nga, no, for 5G. So ganun karami yung pwede natin i-connect na IoT devices. Area traffic capacity from 1 Mbps per square meter to 10 Mbps per square meter. And then of course the energy efficiency, no. Yan. So 10 times or 100 times more than LTE. Okay? So ayan yung ano, no, ayan yung um, targets, no, ni 5G. So meeting this performance targets is essential for the successful deployment of 5G networks and the realization ng full potential of this advanced wireless technology. Although in the early phase of 5G like today, hindi pa natin siya makita lahat, no. For example, sa 20 gigabit per second, you need a very large bandwidth before you can get or more advanced antenna technologies before you get this kind of throughput, no. So kapag may available ng technology for that, maybe we can reach this potential of 20 gigabit per second. Okay, so this is coming from the ITU, no. ITU-R reference, recommendation of the ITU-R of 2083 and 3GPP references. Now, what is the status of 5G, no? All around the world. So this was taken from GSMA last January 2022, but you can see the 5G footprints continues to expand. Meron tayong mga live services available in 70 countries around the world, including Philippines. So ang kagandahan dyan, no, yung 5G pinag-aaralan natin o pinag-uusapan natin today is the same as the 5G na ginagamit sa ibang bansa. Maaaring magkakaiba lang tayo ng frequency or type of transmission, pero yung technology is based from the 3GPP standard, which is world standard, no. So kahit sa mapupuntang bansa, our 5G is the same. Okay, pumunta ka sa Japan, pumunta ka sa Australia, pumunta ka sa Europe, sa North America, okay, sa India, pare-parehas yung 5G natin. Okay? So, yun ang kagandahan, no, sa pag-aaral ng 5G. So, opportunities are not only here locally, but can also be exploited worldwide. Okay? Okay. So, now let's see, no, yung mga different parts, no. How do we implement a 5G system, no? Paano tayo nag-i-implement ng isang 5G system? Okay? So typical 5G implementation, like what we have studied in the radio access network, no? So we have the tower structure, okay, and then you have the remote radio unit or the RRU. Okay, so these are for the legacy users, legacy technology like 2G, 3G, and LTE. Then you have the antenna. Okay, so it must be the same frequency, no, as your radio unit. So kung meron kang 1800, you still need to use 1800 megahertz capable na antenna. And the same thing with the low band. And of course, meron tayong jumper cable. And then meron tayong common public radio interface, which is a fiber optic. So this is an interface that sends data from remote radio unit, no, going to our baseband unit. Yan. Okay. So meron tayong terminology, no, na ginagamit. So CPRI, no, ang tawag natin diyan ngayon. Okay, but for 5G, for a more enhanced connectivity, we will be using EC3 or enhanced CPRI or common public radio interface. So currently, itong CPRI nito is used as front haul connection, okay, from baseband to remote radio unit. Okay, and then the baseband units are usually located inside an outdoor cabinet or a cabin, kung nasaan yung battery supply or backup battery, power supply, ventilation or air conditioning unit, and pati yung transmission. Okay, so for connectivity papuntang core network. Okay, yeah. So in this case, we are using microwave. But in most cases for 5G, we're using a fiber optic, no, para ma-ensure natin yung throughput natin na mas mabilis. Okay? Okay. So, so these are the typical, no, implementation for outdoor. Okay? So if you look at it on the actual implementation, kapag maglalagay tayo ng 5G, you will just need to add this type of antenna, no? So in the industry, it's usually called 5G active antenna unit. Usually these are um, massive MIMO antennas with radios already. So you will hear the word 32T, 32R, 64T, 64R. So meaning there are 64 transmitters and receivers inside this one form factor of antenna. Okay. So pag imagine natin magkasama yan dalawang yan sa isang form factor na to. So kaya siya ganyan ka-compact, no? And ka-complicated. Okay, so when you look at the implementation, ano niyan, so once you have this 5G active antenna unit, so magdadagdag ka lang ng isang 5G baseband unit dito sa baba. Or if capable na yung 5G mo, you just connect it, no, sa 5G BBU. Okay, but most of the time kung legacy yan, so we need to put another BBU. Okay, so yan. And then the connection from the active antenna unit going to the BBU or is what we so-called the enhanced common public radio interface or the EC-PRI. Okay, so if you look at the 5G implementations, okay, so meron tayong may makikita rin kayong GPS antenna for synchronization. So usually you will see this kind of um, device kapag ka ang 5G nyo ay using a TDD frequency or a time division duplex to synchronize, no, each element in the network. Yan. Okay, so ito yung typical example ng isang 5G. Okay, so makita nyo dito yung isang active antenna unit. Yan, yung maliit na yan, ano. Ito yung mga legacy antennas natin. And then some example pa ay ito. Yan. Okay, so meron tayong legacy antenna and ito yung ating massive MIMO antenna designed for 5G. Okay? Yeah, so those are the type of 5G antenna implementation samples. Now let's move on sa different technologies involved in 5G. Okay? So we have the so-called architecture. Okay, ito yung mga pag-usapan natin dyan. So architecture, so is it a non-standalone or a standalone architecture, no? So when we say standalone or non-standalone architecture, teka lang, titingnan natin yan. So when we say standalone and non-standalone architecture, the existing 5G implementation that we have here in the Philippines and the one implemented also in the abroad are what we so called the NSA or the non-standalone mode. So when we say non-standalone mode, we are utilizing the existing core network ng LTE. So usually ito lang yan, no? Yung ating current network, Yan. So meron kang core network, meron kang LTE phone at meron kang LTE base station. So what we will do, you just get an ENG node B or enhanced next generation node B. You will connect it to the E node B. So dalawang BBU yon, magka-connect siya. And then you will connect that BBU to the EPC, to the existing core network ni LTE. That's why it's called non-standalone. So maraming klase ang non-standalone. Marami siyang variants. Pero the main principle to tell that a system is a non-standalone, kapag ka ang core network mo is from one technology and it handles more than one technologies, that is non-standalone. For example, if it's LTE and then you will see an LTE and 5G connected to the core network of LTE, that's non-standalone. And then it will just say it's option 3, option 4, or option 7. No? So maraming options yan. So in this example, we're just talking about option 3. Then option 3 is subdivided further no, into 3 cases. Meron tayong option 3, may option 3A, and may option 3X. So in this example, this is an option 3X. Meaning meron tayong X2 control plane and user plane directly connected sa E node B at G node B. No? And then meron tayong direct connection ng S1 papuntang EPC. Okay. So ito yung ating non-standalone. So the non-standalone supports EMBB or the enhanced mobile broadband. The first use case in 5G. And as I mentioned, it reuses current EPC and LTE as an anchor. And dual connection for user data. So meaning if you are experiencing 5G right now in your mobile phone, nakakita ka ng 5G signal, your phone is connected simultaneously with an LTE and a 5G system. Okay, so ang tawag natin dyan ay dual connectivity. So this is the non-standalone mode. And ang ating holy grail no, sa 5G is to apply the 3 use cases. The EMBB, the URLLC, and the massive machine type communications. For us to fully utilize those 3 use cases, we need a 5G core network, a powerful 5G core network no, that can give us the end-to-end network slicing so that we can separate virtually itong mga use cases na to sa network natin. So to have that um, 3 use cases, we need this option 2. So this is our main goal no, to have a 5G standalone mode. So when you say standalone mode, so the 5G node B or next generation node B is connected directly into a new 5G core network. Okay? So ito yung ating non-standalone. So it supports the 3 use cases, the enhanced mobile broadband, URLLC, and the massive machine type communications. And the end-to-end network slicing. So later, pag-usapan natin yung end-to-end network slicing. And a new 5G core is needed to build. And it will require good 5G coverage. Okay. Ayan. So ito yung ating 5G, 5G, oops, sorry. 5G non-standalone node and standalone node. Next lang, we'll talk about antenna system. Yan. So, 5G is the technology that utilizes these advanced antenna systems. No? So we have what we so called the massive MIMO or the MIMO, no? Advanced MIMO, no? Or higher level of MIMO. Starting from 4x4 MIMO and 8x8 MIMO. So ano itong mga MIMO na to? No? So when we talk about MIMO, okay, wait. When we talk about MIMO, yan. So MIMO tayo. Oops. Okay. Dito ko itong aking ano. Yan. So we talk about MIMO. MIMO means multiple input, multiple output. Yan. So katulad nung pinag-usapan nating analogy no, ng kalsada. Okay, for example, meron ka ipapadalang data, isang package, no? Lazada package. And then you want to deliver is nasa 40 packages, no? Yung papadala mo. And then yung isang sasakyan, ang kaya niya lang ipadala is 10, no? 10 packages per vehicle. So imagine the time needed if isa lang yung sasakyan na gagamitin mo. So meron kang 10 packages, papadala mo one time, and then babalik na naman yun, tapos papadala mo naman one time, babalik na naman, papadala mo one time. So pumapatak ka lang ng ano, no? Pumapatak ka lang ng 40 packages, no, per hour kung isang oras ang kailangan mo. So ganun ka bilis, no. But if you will use 4 channels, no, 4 streams, 4 na sasakyan ang gagamitin mo. So yung 4 streams na yan, yung 4 na sasakyan na yan, ilagay mo yung tig sa 10, no, 10 packages per sasakyan. And then pag-deliverin mo sila ng sabay-sabay. So meaning in parallel 10 sasakyan with the 4 na sasakyan with the 10 packages each. So 40 packages per hour ang magiging rate mo. So that is 4 times faster than a 1:1 na transmission. So that is MIMO. Okay? Multiple input, multiple output. Okay? So multiple yung transmissions mo, sabay-sabay. Okay? So meron naman tayong tinatawag na SIMO, no? So SIMO is isa lang yung single mo, isa lang yung output mo, but your reception are multiple, no? So these are happening especially if meron kang diversity na receiver diversity sa receiver mo, no? So kung may mangyari man dito na aberya, may na-block ditong signal, so at least meron ka pang 4 na receptions, no? May 3 ka pang natitirang receptions. So ang tawag dito ay SIMO or single input, multiple output. Meron naman tayong tinatawag na MISO, no? Yan. So MISO is multiple input and single output. Okay, so meron tayong mataas yung antenna configuration ng site natin, but the mobile equipment is only one receiver, no? Yan. So MISO to, no? Yan, sarap yan pagkatanghalian. And then SISO. SISO is single input, single output. So most of the time nakikita natin 'to sa mga in-building solutions. So meron kang isang transmitter and then meron kang isang kable papunta sa isang antenna. So that's a single transmit and then single receive, no. Ayan, so SISO ang tawag natin diyan. So pwede natin implement din ng ganyan, no. Pero if we want to maximize the potential of 5G, no, we want to use MIMO. Yan. Bakit? Sayang naman, no, kung papadaanin mo yung Ferrari mo sa ano, sa lubak-lubak na daan, no, or sa isang kalsada lang, no, o sa masikip na kalsada. So if you want to maximize the performance of your Ferrari, so you need to give it a more advanced technology like MIMO rin, no. So ganun ganun din yun, ano. Okay, so this is MIMO. So marami rin tayong types of MIMO. So meron tayong 4x4 MIMO. Yan. So meron tayong 4 transmit and then 4 receive. Yan. Meron tayong 4x2 MIMO. Okay. Meron tayong 4 transmit and then 4 receive, 2 receive. Meron tayong 8x8. Okay. So far ito yung pinakamataas na configuration. I'm not sure kung meron ng 16x16 pero most of the configuration nakita ko is 8x8. And then 2x4. Yan. 2x4 MIMO. So anong benefits ng MIMO, no? Bakit tayo gumagamit niya aside from faster throughput? Okay? So meron tayong tatlong benefits, no? So we have what we so called the diversity gain. Yan. So ano yung diversity gain, sir? So yung diversity gain, para meron kang backup, no? Backup na daan, na path. So kung mag-fail itong path na to, may nag-obstruct or nag-reflect, meron ka pang isang path na i-consider. So we call it diversity gain. So it reduces the impact of fading when the fades of each propagation paths are uncorrelated. Okay, so meron tayong backup, no? Yan. Meron tayo isa pang diversion. Kung ma-block man yung road na yun, meron pa tayo isang kalsadang dadaanan. So that is the diversity gain. And then we also have this array gain. Ito yung pinakamasakit sa lahat, no? Na gain. Kasi napa-array siya. Array. Yan, medyo medyo slang, no? So si array gain. Array gain is achieved from the beginning, from the beamforming effect. Yan. Kapag ka nagbi-beamforming tayo, no? Ibig sabihin ng beamforming, we are aligning or we are aligning yung mga antenna elements natin to capitalize yung tinatawag nating constructive and deconstructive interference, right? So if we are capitalizing that, so we are focusing our energy into a certain direction. So and then we call it the array gain. So mas nagiging focus siya. So paano nangyayari yun, sir? Imagine meron kang isang bulb. So kapag yung bulb niya hawak-hawak mo lang sa kamay, so the electromagnetic energy is radiating omnidirectionally. But if you want to focus the energy, and then you want to have this kind of array gain, so you will put it in a reflector, katulad ng flashlight. Okay. And then you can focus the beam, no? Yan. So nagkaroon tayo tawag na array gain. Yan. So yung beam forming. No? So mas lumakas or na-concentrate yung ating electromagnetic energy into the direction that we intended to transmit it. Okay? Yan. Yan ang pinakamasakit, no? RI gain. And then the other one is spatial multiplexing gain. Yan. So the spatial multiplexing gain increased throughput by transferring multiple streams of data in parallel. So marami tayong ano, no? So ito yung sa tawag nating times 2, times 4, times 8, no? Na ginawa natin example kanina. So in parallel using the same set of time and frequency domain resources. So multiply mo ng 2 yung transmission dahil meron kang different spatial multiplexing gain. Okay? Now, ano pagkakaiba ng beamforming, no, and massive MIMO? So when we say beamforming, it provides a higher spectral efficiency, which adds more capacity and improves link performance and extend coverage. Bakit sinasabi natin na nag-i-improve yung spectral efficiency and adds more capacity? Sa mga legacy technology natin like 2G, 3G, and sometimes 4G, no, na hindi pa gumagamit ng massive MIMO. Kapag ka nagka-transmit tayo, no, pag nagka-transmit tayo sa isang antenna, for example, ito yung antenna natin, ano, top view to, no, nag-transmit tayo dito. So, typical yung transmission natin is kalat yan, no? Naka 65-degree beam width and kalat. And then, kino-cover natin yung mga subscribers natin dyan. Okay. Kung wala naman tayo mga subscribers dito, wala tayong subscriber dito, wala tayong subscriber dito, wala tayong subscriber dito. Sayang yung energy, no? Sayang electromagnetic energy. So, mas maganda sana kung naibigay lang natin yung ating atensyon at focus dun sa mga importanteng subscribers natin. Yan. Yung kagandahan sa beamforming. You can focus your energy, okay, your electromagnetic energy to the intended subscribers, no? Especially for 5G. So kapag naka-focus ka sa isang bagay, naging philosophical, ano? Pag naging focus ka sa isang bagay, mas malakas talaga yung impact nun, diba? Kesa shotgun effect ang ginagawa natin. So, ganun yung nagagawa ng beamforming. Dahil nafo-focus natin yung beam natin, nagiging flashlight siya, no? So, mas nagiging malakas yung receive signals natin doon. So, kapag may flashlight ka, right? So, mas naiilawan mo ng husto yung gusto mong i-cover or makita na area. So, ito yung beamforming. So, the beamforming is not a new technology. Matagal na yung ginagamit, no? Lalo na sa mga radar systems, ginagamit na yan. And then sa mga detections, so ginagamit na yan. Inaano lang, ini-improve lang natin and applied sa cellular technology. And then, dumating itong massive MIMO. Yan. So, the massive MIMO is the extension of the traditional MIMO technology. Dinagdagan lang na salitang massive dahil mas marami. Okay? Imagine yung isang beam. So, itong beam na to ng antenna. So, dati, ang beam ng isang site is equal to this one. Right? Equal to this one. Tapos, meron kang isang radio. Okay? So, ayun yung original natin. Now, kapag magdadagdag tayo ng capacity, so typical, magdadagdag tayo ng radyo, nagdadagdag tayo ng antenna. So, meron tayo mga ganong klaseng implementation. But if we implement massive MIMO, for example, 62T, 6040, 6040, 64R, imagine there is a 64 transmitter here. 64 transmitter there sa isang ano. And then meron siyang 8 beams na ganyan. Okay? Hinati-hati natin yan. And then naka-focus yan sa mga subscribers natin. Okay? So hindi na siya isang beam lang na parang shotgun effect, pero ito ay naka-focus yung ating mga beams sa ating mga subscriber. So dahil marami yung beams na yan, so we call it massive. And then each beam can be configured from 44R or 4x4 MIMO up to 8x8 MIMO. Kaya tinawag na massive MIMO. Marami siyang MIMO, no, na-apply sa isang antenna lang. Okay? Ayan, so 3GPP is the one defining massive MIMO as more than 8 transmitter. Okay? And beams can be formed in the number of different ways. So pwede tayo magkaroon ng fixed grid of beams. Pwede yan naka-fix. Or user equipment specific beamforming. So tinitingnan niya kung nasan yung user, concentration ng user, Pag nag-transmit si user ng kanyang estimated location through the signal, no? Yung kanyang CRS, mangyari, yung ating antenna, yung ating adaptive MIMO will configure, no, the necessary beams needed, no, to fully cover itong area na yan. Yeah. So ito tawag ating 3D massive MIMO naman. So it's an advanced application of MIMO. Okay? So yun yung ating beamforming and massive MIMO. So when you look at the antenna of a massive MIMO design, ganito yan. No? So meron kang massive MIMO antenna, meron kang antenna sa loob. So typical, ito talaga yung antenna niyan. Ano? So the number of antenna elements, no, yung mga ano natin, ano, mga antenna elements natin sa loob. So they are cut into half of the wavelength ng ating frequency. Yan. So when we say 192 antenna elements, so naka-align yan dito ng gano'n. No? So meron tayong 1, 2, 3, 4, 5, 6, 7, 8, 8 by 12, and then meron kang 45 degrees plus minus and 45 degrees. Hindi ko kaya, ngayon, hindi yan nakanta, no? Yan. Nakaganon yan, 45 plus and minus 45 degrees. So if you calculate the number of antenna element is equivalent to 192 antenna elements. So ang ginagawa ng massive MIMO, dahil kinakapitalize natin yung constructive and deconstructive interference, it selects, no, yung number of antenna elements na pwede tayong magkaroon ng beam. Okay? Ayan. So sineselect niya yan para nagkakaroon tayo ng beam. So dito nangyayari yung tag na beam forming. No? Yan. Yan. So nagkakaroon tayo ng beam. So hindi yan nagka-transmit ng isang buga lang. Nagka-transmit ng maraming beams. No? So nakita ko is 8 beams pwede niya i-transmit. Okay? So using this number of antenna elements. So this is the design factor. No? Now if you look at the antenna size, no, ng isang massive MIMO. Ayan, ito yung sabi natin. Ano. For example, meron kang frequency na gagamitin which is 3.5 GHz. So ito yung kalsada natin na binabanggit na SLEX, NLEX, CCLEX. Okay, so 3.5 GHz yan. So 1 GHz hanggang 6 GHz. Now, if we will design a massive MIMO antenna size, ang difference ng antenna element from one antenna element to another antenna element must be half of the wavelength para makakapitalize natin yung constructive and deconstructive interference. So once na half the wavelength yan, so makikita mo na makakalculate natin kung meron tayong 12 rows in a vertical direction and meron tayong 8 rows in horizontal direction, pag kinalculate mo yung lambda niyan, yung wavelength niyan is lambda is C over F, right? So this is speed of light, 3 times 10 to the 8 meter per second. And this is the frequency. So 1 over T, no? 1 of the period. 1 over period. So, meron kang 3.5 gigahertz. So the wavelength would be 8.6 centimeter. Now, if you will get the half of the wavelength of the 8.6, that is equivalent to 4.3 centimeter. Now, 4.3 centimeters, kung ang 4.3 centimeters ang difference itong mga to, okay, so you will see that the antenna height in practice could be 60 centimeter. And you will see that the antenna width, yung lapad ng antenna mo is 39 centimeters. So in practice, ginagawa natin 40 centimeters yan. So less than 1 meter yan, no? Yung ating mga antennas. No? Okay. So ganyan nagdi-design ng mga massive MIMO. Kaya makita mo, meron tayong mga antennas na iba-iba, no? Yung itsura, iba-iba yung haba niya. Yun ang dahilan kung bakit iba-iba yan dahil sa frequency. Okay? So dahil sa frequency niya ng ng um, na ginagamit ng isang technology. Okay? So may nakita kayong mga antena mahaba, meron kayong makita mga antena mga maikli katulad ng massive MIMO antena. Okay? Ayan. So ito yung isang example ng massive MIMO antenna. So care of Nokia. So this is an AirScale massive MIMO adaptive antenna. So less than 1 meter yan ang haba at nasa 0.4 meter yung lapad niyan. Ito yung mga antenna elements. So 1, 2, 3. Yan. So ito naman yung pagkakahati-hati, no, nung kanyang mga antenna arrays. Okay? Ayan. So ito yung ating um, massive MIMO, no? Okay, so clear ba 'yon, yung ating massive MIMO antenna? So importante 'yun, ano, maintindihan natin yung massive MIMO antenna. So that is the antenna system, no? So ano man, ano, apology sa ano, no, sa nag-aano kasi itong slide ko, sariling buhay. Okay. So that is the antenna system, okay, that we have to consider in massive MIMO. What's next, no? So kung meron tayong antenna system, so we'll have the frequency na kailangan i-consider sa 5G. So sa 5G, we have two types of frequency. Okay, two major categories of frequency. The frequency range 1, the FR1, and the frequency range 2 or DFR2. Ano pagkakaiba niyan, sir? So the frequency range 1, these are the frequencies, hold on, these are the frequencies less than 1 gigahertz. Yan. Teka, puntahan natin yung frequency na yan. Yan. Ito yung ating mga frequencies, no? Yan. So marami tayong range of frequencies, no? So si 5G actually is the only technology na alam ko na from 450 megahertz up to 71 gigahertz. So, siya lang. Yan. Wala nang iba. Okay. So meron tayong dalawang frequency ranges. So ito yung frequency range 1. So pag tiningnan niyo yan, so from 1 gigahertz up to 100 gigahertz, no, yung frequency. Ito yung mga kalsada natin. So nandito yung frequency range 1. So nandito si 900, 450, okay? So nagsta-start ang frequency range 1 sa 470 megahertz up to 6 gigahertz. Yan. So kapag ka nandiyan yung range niyan, that is considered as frequency range 1. Okay? Frequency range 1. So this is also called the low frequency. So na-develop yan nung napagka-agreehan yan sa ITU ng ITUR nung World Radio Congress, no, Conference nung 2015. Yan, kaya yung WRC 2015. And then nung 2019 nag-convene ulit sila, no, sa Egypt para pag-usapan naman yung panibagong range of frequencies na pwedeng gamitin. So pinag-aagrihan yan, no, ng mga standardization bodies, particularly in the International Telecommunications Union. So tinatawag niya yung mga delegations or mga partners, ano bang pwede nating idagdag, no, na frequency. So nung World Radio Conference nung 2019, dinagdag nila yung 24.25 gigahertz up to 86 gigahertz. Yan. So mga high frequency yan. So tinatawag natin itong millimeter wave. Yan. So kapag may narinig kayong millimeter wave, actually ano yun, no? Hindi naman siya technology, frequency yun eh. Okay? So ayun yung frequency ginagamit natin sa 5G. Ang consideration talaga, ang main consideration na dapat natin isipin dito is yung ano yung performance ng mga high frequencies na yan. So most of those frequencies are affected na ng ano, no, ng mga some weather conditions like rain, okay? Kapag umuulan, medyo affected na yung mga high frequencies na yan, ano. Yan. Oxygen absorption, so may mga ganun na, no. Pero dito sa mga low frequencies, ang pinaka main ano lang natin dito is obstructions eh. Obstructions, fading, yan. Pero dito, meron na tayong environmental concerns, no? Hindi naman, ano ba tawag doon? Climate concerns or weather, no? Yan. So, yun yung mga kino-consider natin dito. So, dalawa yung frequency range natin, no? Frequency range 1 and frequency range 2. Now, if we will compare it sa 4G frequencies, ganito ang difference nila. Okay? So, kung meron akong isang single frequency, no, na pagkukumparan together with 5G, si 4G meron lang tayong 6 na bands eh. 6 na bandwidth eh. Meron tayong 1.4, 3, 5 megahertz, 10 megahertz, and 20 megahertz. Kapag gusto nating gumamit more than 20 megahertz, hindi na kaya. So we need to add another carrier. And that mechanism is what we call the carrier aggregation. Okay, so more than 20 megahertz, gusto mo pang lakihan yung bandwidth mo. So you need another frequency and then combine it, no? So we call it the carrier aggregation. Pero sa 5G, okay, sa 5G, we can deploy 40, 60, 80, 100 megahertz up to 400 megahertz. Okay? Although pwede rin naman tayo mag-deploy less than 40, pero hindi na natin ma-maximize yung capability. So imagine yung bandwidth natin, di ba? Ito yung lapad nung frequency band. So sa analogy natin, this is the width ng kalsada. Okay? Gusto mo bang padaanin ang iyong Ferrari sa eskinita? Katulad ng 5 megahertz or 1.4 megahertz. Gagasgas yun. Diba? Hindi natin gusto yun. So we want to maximize yung performance ng Ferrari natin. Gumamit tayo ng mga wide roads. No? Yun ang masarap paandarin. No? Yan. So kaya ang mga suggestions dito is 40, 60, 80, 100, up to 400 kung available sa country yung ganyang klaseng bandwidth. Okay, so yung 60 megahertz na mga trials na nakita natin, ito yung nag-give way sa 1 gigabit per second. Yan, most of the trials na nakita ko ito. Yan, sa calculation din na ginagawa namin, kaya natin makakuha ng 1,000 Mbps kapag ka 60 megahertz ang ginamit natin. Okay? Clear po ba ito? So far so good? Can I get a thumbs up? Kung clear pa tayo? Okay. So, tuloy natin discussion and then after this, maybe you can take a 5-minute break. Okay? So, tapusin lang natin itong frequency natin. So, meron tayong, kung ito yung ating macro view ng mga frequencies, ito naman yung ating detailed view. Yan. Okay? So, sorry, ito pala. No? Detailed view. Yan. So, meron tayong FR1, FR2, okay? So ito yung detailed ng mga frequency bands. Ito yung mga bands ng FR1. Marami yung frequency niya, no? And even yung mga frequencies na ginagamit natin for GSM, 3G, and 4G are also applicable dun sa ating 5G system. So, sir, pwede ba yon? Pwede ba natin gamitin yung frequency dati ng 2G, 3G, at 4G sa 5G? Yes, pwede. Kasi frequency lang naman yan. Kalsada pa rin yan. Ano? So, yung technology is the Ferrari. Yung sasakyan. Okay? So, compare mo yung mga sasakyan mo. For example, yung 2G is the um yung ang tawag ng kuliglig. The kuliglig, no? Yung kuliglig yung nasa alam mo yung kuliglig, yung mga nasa provinces, yung malalaking traktora na malalaki yung gulong. Yeah. So hindi naman yun pwede sa NLEX, ano. Pwede mo naman padaanin sa NLEX yun, kaso marami siyang madidisturb, no. So doon lang siya sa mga lubak-lubak, maninipis na kalsada. Yan. So kuliglig is for kasi mabagal lang yun eh. Yung 3G natin could be compared sa ayan, yung mga Toyota Vios natin, okay? Yung mga Altis, yan. Lancer, may Lancer pa ba? Yan, mga ganun. Yung mga typical natin, typical cars natin. Pero pagdating sa 5G, we can compare sa mga muscle cars natin. Yan, mga muscle cars natin. So, kinakailangan natin ng yun ang technology natin. No? So, imagine yung technology. And the frequency, ito yung kalsada. No? When we talk about frequency, always use the analogy of the road, the kalsada. Because that's the best way to represent it. No? Para mas madali rin maintindihan ng mga students natin. So, kung meron kang 5G technology at meron ka namang, for example, 3G or LTE frequencies, no? Pwede mo padaanin din doon. Basta sufficient yung kanyang bandwidth. Pwede yon. And then, nandito rin naman supported siya internationally. Yan. Okay, so kinakailangan mo lang tignan, syempre, yung mga telepono. Kung marami kayong telepono or subscribers na merong frequency under these bands. Okay, yan. So ito yung mga FR1 at FR2. And then ito yung FR2 natin. No? So, ito yung mga millimeter waves natin. So, you will see, yung mga millimeter waves natin are TDD lahat, no? Time division duplex. So, yung inassign na, no? ITU. Bakit siya naka-TDD? Okay? So, yeah, that's our discussion for the initial discussion for 5G. So let's have a short break muna para mga 5-minute break para makapag-refresh kayo and then we'll continue the discussion papunta sa iba't iba pang features ng 5G. Okay? So napag-usapan na natin yung architecture. So meron tayong non-standalone mode at standalone mode. Okay? So it depends kung saan core network nakasaksak yung 5G mo. And then pinag-usapan natin yung antenna system, the massive MIMO or the 8x8 MIMO or 4x4 MIMO. And then meron din tayong mga frequency. So the frequencies are categorized into FR1 or FR2. Okay? Now, pag-usapan naman natin is the transmission mode. So si 5G katulad ni 3G, ni LTE at may ibang technology, we can use it as a time division duplex and frequency division duplex. Okay? So ano yung time division duplex at frequency division duplex, no? So ang time division duplex, ang frequency division duplex katulad ng pinag-usapan natin sa radio access network, okay? Meron tayong communication channel, 'di ba, na ginagamit from mobile station going to your G node B. Okay, or sa next generation node B or UE, no? So ang tawag natin sa channel na 'yon from your phone going to our base station is the uplink. Okay? And then from the G node B naman, pababa ng inyong user equipment or yung telepono, we call it the downlink. Kapag ka ang uplink at yung downlink mo, okay, directions, are using different set of frequencies, okay, magkaiba sila ng channel, we call it the frequency division duplex, no, or the FDD. However, kung ito naman ay magkasama, no, sa isang sa isang frequency lang, yan. So, ang tawag natin diyan ay time division duplex. Okay? So, ibig sabihin, they are only separated by time. Okay? So, ayun yung ating modes of operation. So, most of the FDD, yung mga frequency division duplex natin, no, na mga frequencies or mode of operation of 5G, ito yung mga less than 1 gigahertz, no, na ginagamit natin. Ito yung mga less than 1 gigahertz, no, na ginagamit. So kapag TDD naman, ito yung mga high frequencies natin. So most of those are using the TDD mode. Okay? So ang tawag natin dyan sa dalawang modes of operation ay FDD at TDD. So usually magkadugtong yan. Meron tayong FR1 tapos FDD. And then meron tayong FR2, most of them are TDD. So merong mga special cases na naka FR1 ka, frequency range 1, pero FDD or TDD ka. Okay, so it depends sa ano mo. Sa frequency band na ginagamit mo. So both FDD and TDD are essential, no, sa efficient use ng radio spectrum and have specific applications depending on the network requirements. Kasama rin yung geographic and of course yung regulatory constraints and the desired balance between the uplink and the downlink data transmission. Okay? Okay. So ito yung transmission mode natin. So meron tayong TDD at FDD. So meron din tayo syempre yung voice services sa 5G. Okay? So pag sinabi natin mga voice services, makakatawag ba tayo sa 5G, sir? Yun ang unang tanong dyan, no? Makakatawag ba tayo sa 5G? So yes, makakatawag tayo sa 5G, no? So sa bawat configuration ng 5G na ginagamit natin, we can set up a call. So currently ngayon sa LTE, we can do mga ano na, mga voice services. So, for example, ngayon, naka-LTE ka. So, you can check on your phone. Kung naka-LTE ka ngayon, and then hindi naka-activate yung voice over LTE mo or VoLTE, no? Kung hindi naka-activate yan, try mo mag-dial ng number dun sa keypad ng phone mo and then try to call somebody. Ang mangyayari dyan, from LTE, magiging 3G yan or 2G. Okay, so yung mechanism na yan, ang tawag natin is CS fallback or the circuit switch fallback. Okay, so ibig sabihin from LTE, your call is diverted or going down to the network ng 3G para dun ka tumawag, no? Dun ka mag-establish ng voice call. Kasi ang voice call ng 2G at 3G are what we so called the circuit switch. Parang telepono pa rin yan, no, yung landline natin. So when you pick up the phone, ang nangyayari doon, you close a certain circuit. Now, mula doon sa terminal mo, papunta sa central office. So, kaya siya tinawag na circuit switch. So, pag angat mo doon, pag baba mo doon, mag-o-open yung circuit. So, mapuputol na yung connection mo and then maibibigay yung panibagong resource na yon sa ibang subscriber. So, circuit switch yun. Pagdating sa 2G at 3G, naging digital yon. Okay? So, nung dumating yung LTE, kung hindi pa activated yung VoLTE, your call will be pushed, no, from LTE going to 3G and 2G. Pero kung activated na yung VoLTE, so there is a part of the core network, we call it the IP multimedia subsystem. So that is the one handling the VoLTE calls. Kaya kapag ka naka-VoLTE ka, naka-activate yung VoLTE mo, ang mangyayari dyan, when you try to call somebody, naka-VoLTE ka, hindi ka mawawala sa LTE. Okay, so naka-packet call ka na, volte ang ano mo, volte ang connection mo through the voice call. Ang kagandahan nun, kung ikaw ay nanonood or may tumawag sa iyo, yung nagda-download ka, or example nagda-download ka, yung connection mo sa LTE hindi mapuputol. Kasi ang isa sa mga drawback ng CS fallback is kapag ka nag-fallback ka sa 2G or 3G, yung data connection mo pupunta rin sa 2G, no, or sa 3G, which is mas mabagal yung data mo. Okay? Ayan. So, meron tayong mga different voice calls. For example, ito yung option 3. Okay? So, this is a non-standalone mode. Okay? So, ito yung core network natin, may LTE and NR. And then, we have the option 2. Okay? So, ito yung 5G and NR. You have the option 4. Meron din tayo niyan. So, may mga countries na ganito ginagawa. Okay? So, 5G core network, may NR, and then may LTE siya. Uh, Option 7, 5G core network na siya, pero LTE nakakabit and then nakadugtong lang si NR. And then meron naman tayo option 5, which is a 5G core network tapos naka-LTE ka. Okay? So meron tayo dito, pwede tayo pa ring tumawag using the voice or the over the top VoIP or OTT. Kasama dyan yung Messenger, Viber, Skype. So kapag ka meron kang data connection, pwede ka tumawag. So voice over IP. Okay? So lahat yan merong voice over IP. Dito sa case na to is CS fallback. Ito yung sabi natin kanina, no, from NR to LTE bababa yan ng 2G or 3G. Meron matitawag na EPS fallback which is bababa siya sa LTE. Okay? At then doon ka tatawag. Also same din, no, yung sa RAT fallback, so radio access technology fallback. And then meron tayong na VoLTE, kung active yung VoLTE dito at ito nakakabit sa IMS. And kung yung 5G naman ang active na nakakabit sa IMS, we call it the VoNR or the voice over NR. Although ito magkaiba lang ng pangalan, ano, kasi ang nangyari is it's a typical VoLTE din. Pero since the main node is connected to the core network, tinatawag siya in some terminologies or books. Ang tawag sa kanya is VoE-LTE. VoLTE rin yan, no? Kasi pag ang LTE yan nakakonekta sa 5G core network, we call it the enhanced LTE. Okay? Yan. So, VoE-LTE. Pero VoLTE variant din yan. Okay? So, ang sagot sa tanong na pwede ba tumawag sa 5G? Yes. So, three mechanisms, no? So, voice over IP, CS fallback, at true VoLTE or VoNR. Okay? And then next is puntahan na natin um, yung isa pang last ano natin ano, last natin na slide. Last na pag-uusapan natin about hindi pa pala, no, second to the last, the location. Yan, location. So meron tayong mga 5G or base stations na hindi nakatanim sa lupa. Okay, so you will hear more of this, no, lalo na kapag very familiar kayo kay Starlink, no. Yan. So meron tayong dalawang klase ng ano, location ng network. Meron tayong tinatawag na terrestrial network. So ito yung mga network or base stations na nakatanim sa lupa, o nakalapag sa lupa. So we call it terrestrial. Okay? So itong typical example natin, yung towers na yan, mga rooftop, nasa building, nakalapat sa lupa yan, terrestrial networks yan. Kapag ka ang iyong network equipment ay naging spaceborne, okay, umangat, lumipad, for example, drone or high altitude platform system, HAPS, or nilagay natin sa satellite, okay, ginawa nating low Earth orbit, okay. So ang tawag natin diyan is NTN. Ano sir yung NTN? So hindi na siya terrestrial. Ano siya? Non-terrestrial network sa siya. Okay, so ganoon siya kadali, no? Kapag lumilipad na, hindi na siya terrestrial, ang tawag na natin ay non-terrestrial networks. Okay? So, ano yung mga examples ng non-terrestrial network? Let me just see, no, kung meron ditong non-terrestrial network. The example, ito. Um, Tingnan natin kung ito yung slide na yon. Ayan. Okay, so mga unmanned aerial vehicle. Okay, so meron tayong classifications ng non-terrestrial. So, may mga non-terrestrial tayo na depende sa altitude. Okay? So for example, yung mga drones natin, yan, yung mga drone applications na connected sa network, minsan nilalagyan natin yan ng mga micro base stations sa ano rin, na kaya nilang idalhin, no? So we call it the drone, no? Unmanned aerial vehicle. And then meron tayong tinatawag na HAPS. Ito yung mga HAPS natin. Yan. So mga high altitude platform station. So, ang taas niyan is 7 kilometers to 20 kilometers above the ground. So, sa Japan, meron silang tinetest na ganyan. So, lumilipad lang yan paikot-ikot. So, mas malaki ang coverage niyan compared sa mga terrestrial network kasi nasa taas siya. And then, sumunod na dyan is yung uh, low Earth orbit natin, yung mga satellite na communications natin. Actually, yung satellite, pwede siya maging low Earth orbit, merong MEO, okay? And then, meron tayong geostationary orbit. No? Yan. Pero most of the applications na ginagamit natin is the low Earth orbit, katulad ni Starlink. Okay? Yan. So, ayun yung non-terrestrial networks natin. Okay? So, meron tayong location, no? So, ang 5G pala, pwede rin tayong terrestrial at non-terrestrial. Okay? And of course, yung last na application natin ng 5G na pwede na i-consider, ano ba to? Private ba to? Or public network? So kapag ka na-access siya ng public using a typical SIM card, okay, kapag bumili ka ng SIM card, nag-register ka, nilagay mo sa phone mo, na-access mo yung network, that is a public network. So meaning, it's open to the public, no, for everybody's youth. Okay? Pero once na nagkaroon ng restriction for public, nagkaroon ng gateway, no, or nagkaroon ng barrier for you to connect to that specific network, we call it a private network. So non-public network ang tawag natin dyan. NPN. So para mas madaling tandaan, hindi siya public. So non-public network, NPN. Okay? So ina-apply natin itong mga NPN or the private network sa mga factories. Yan. Sa mga corporations na meron na gusto nilang palitan yung kanilang Wi-Fi system using a 5G network, no? So ang tawag natin yan is non-public network. So dun sa mga areas na merong automation, okay, yung mga production lines, gusto nila yung mga robots nila ay connected through 5G. So nagkakabit sila ng tinatawag na private 5G network sa loob. So isa rin ito sa titing ng ano, no, isang business model ng mga operators na to offer a non-public network or a private network to an entity. So it's a business to business model, no? B2B model. Ito kasing public network, most of the time it's B2C, no? Business to customer. So meron kang network, bibili yung customer mo direct to the subscribers. So just buy a SIM card, load yung ano mo, loadan mo yung SIM card mo. So that's a B2C model. Meron naman tayong tinatawag na B2B, no? Business to business. So merong isang entity, merong isang corporation, they want to have their own private network, 5G, and then they want to connect all the IoT system in their factory or in their company. So they can buy a slice, no, dun sa kanilang they can buy a slice, no, dun sa network ng operator. So ano yung mga example ng private network, no? So let me just check that one. So tingnan muna natin tong network slicing. Yan. So sa network slicing, no? Ito muna ng private network. Yan. So si private network, meron tayong apat na cases. So we have the what we so called standalone. Okay? So yung enterprise, meron siyang sariling frequency, okay? Meron siyang sariling core network. So they can do their own their own um private network. So in this model, yung enterprise owns and operates its own radio access network and core network. Mayaman to, no? And creating an entirely independent network. Yan. That is isolated sa public. Talaga hindi mo siya hindi mo siya ma-access. So, ang kagandahan diyan, it allows for complete control over the network infrastructure, data and security. Ang kaano lang diyan, ang downside lang yan, syempre yung maintenance, okay, and then yung expertise ng mga engineers nila diyan. Kung meron silang sapat na expertise to maintain yung kanilang standalone network. Para kang may sariling Wi-Fi system, pero 5G ang technology mo. Next is itong hosted by MNO. Yan. So, itong setup na to, hosted by MNO, the mobile network operator, pag sinabi natin MNO, it's the mobile network operator. It hosts the private network. So, sila yung may sagot niyan. So, mula hardware, software, services, no? So, the enterprise RAN is connected to the MNO's core network. Yan. So, nakakabit kayo sa core network ng mobile network operator. So ang kagandahan niyan, yung enterprise will benefit from the established network ng MNO. Okay, so kung kakabit ka kay Globe at Smart, mas madali yung maintenance niyan. Okay, magbabayad ka na lang ng monthly subscription or payment. Okay, ayan yun. Ito yung hosted by MNO. And yung isa naman is the RAN sharing. Yan, RAN sharing naman, no? So sa RAN sharing, in this scenario, the enterprise shares the RAN. So magkasama yung inyong radio access network, no? So pwede itong gamitin ng no, meron kang dalawang operator, tapos pwedeng dalawa silang mag-serve sa'yo sa loob. So for example, no, meron kang smart, meron ka ring Globe, pwede mo silang pagsamahin sa isang equipment and then magkahiwalay sila ng core network. So ang tawag natin doon is RAN sharing. So instead na gagamit yung mga operators or mobile network operators na magkaibang equipment which will take a lot of space dun sa area. So might as well share the hardware, yung RAN, no? So pwede namang hindi siya mobile network operator, pwedeng private entity siya na meron siyang sariling frequency, no? So pwede pa rin yun, no? RAN sharing pa rin. Okay? So ang tawag natin yan is RAN sharing. Okay? So it's an hybrid approach, no, that allows yung mga enterprise to control its core network. Ang maganda rito, meron kang sariling core network. Hindi ka nakiki-core network sa mobile network operator. Nakiki-run share ka lang sa kanya. Pero meron kang sariling core. So walang access yung mobile network operator dun sa sarili mong core network. Okay? And the other one is the MNO slice. Yan. So, MNO slice or mobile network operator slice. So, gagamit tayo ng terminology dito, the network slicing. Yan, i-slice na. Gagano pa tayo. Network slicing, no? Yan. So, nag-slice tayo. So, network slicing is a key feature ng 5G. Yan. So, kung saan yung mobile network operator creates a dedicated slice. Binibigyan kanya ng virtual path, no, for your network enterprise. No? So yung slice na yan logically separated from the mobile network operator. For example, meron tong naka-public to. So binibigyan kanya ng sarili mong slice. Parang private network, no? Virtual private network. Yan. Okay? So ang maganda diyan, yung mga hardware na kinakailangan, okay? So hindi mo na kailangang bilhin, no? So bibili ka na lang ng slice. So typical naka-embed yun sa SIM card mo kung anong slice ang bibilin mo sa network. For example, EMBB slice or pwedeng URLLC or pwedeng IoT or massive machine type communication slice. Okay, so it depends doon sa bibili mong slice. So para mabigyan kanya ng panibagong virtual connection or virtual slice. So yung mga bawat component niyan, bawat options niyan, meron yung different levels of control. So nasa private network, nasa private enterprise na lang kung anong gusto niyang control, level of control. Gusto niya bang full control? So punta siya sa standalone. Pero mayroong drawback 'yon kasi nga yung expertise, yung maintenance, no, yung troubleshooting, sa kanya lahat 'yan. Pag hosted by MNO, so yung kanyang data ay nasa MNO, no? Kapag run sharing naman, nasa iyo yung core network, nakikishare ka sa radio access network. Meron kayong share. Pagka MNO naman, meron ka lang slice sa network. So, services ang talagang binibili mo sa kanya. No? And then, pwede rin makuha mo yung core network. Sa iyo yung core network. So, it depends on the level of control, level of investment, magkano yung budget mo for that kind of private network. And of course, yung integration sa public network. Gusto mo ba talagang separate ka sa public or gusto mong ma-access din ng public yung system, no? So it depends, no, sa sa objective ng enterprise, no. So ang kagandahan diyan, meron kang flexible choices for your specific 5G network requirements. So yun ang kagandahan sa private network. So when we talk about slicing, no, dito sa MNO, so ang slicing means ano ganito ang itsura ng slicing. No? So literal sinislice yung So a network slice is a service-based logical network. Okay? On a common shared hardware. So isang hardware yan. So meron ka lang logical network. No? Binibigyan mo ng logical network. So it provides yung end-to-end QoS, no? With optimal resource sharing. Okay? So ano yung QoS again sa? Quality of service. So balik tayo dun sa analogy natin ng kalsada. No? So lahat tayo pwede gumamit ng kalsada, right? So unless it's private kalsada or a private road. So dumadaan tayo sa NLEX or sa Skyway, okay? Gadrive tayo sa Skyway or sa EDSA. Traffic na, no? Kasi congested na, ang dami gumagamit ng resource natin. And then suddenly may narinig ka. Winga, winga, winga. Winga, ano? Ambulansya, police, no? Or yung mga motor na malalaki. Hindi ko alam kung ano. Pero may ano sila, may iingay sila, no? So mataas yung QoS ng mga yun. Anong ginagawa natin, no? Kapag mataas ang mga QoS nila, tumatabi tayo. Right? Tumatabi tayo, di ba? So binibigay natin yung resource natin, yung spectrum resource natin. Okay, yung time slot or yung space natin doon sa kalsada para sa kanila. End-to-end QoS ang tawag doon. Are you getting the analogy kung saan yung ano yung QoS? Kasi kung hindi, pare-parehas tayong mababagal. So merong mga services sa network like voice, no? Na hindi niya kailangan ma-delay, no? So kasi ito kailangan real time. Meron naman tayo mga services sa network like email na pwede naman siyang ma-delay, di ba? So kaya kapag ka naka-receive ka ng email, sinabi mo nung kasama mo, in-email ko na sa'yo. Sige, check ko na lang mamaya. So hindi siya ganoon ka time sensitive, right? Pero kapag ka voice call kasi, it's a time sensitive. So kinakailangan kung ano yung sinasabi ng kausap mo, naririnig mo siya almost real time, right? So it's not like that kind of service. Okay, so it provides end-to-end QoS. So meron tayong three major types of slices. Ano yung three major types of slices? Hulaan natin. Siyempre, ito yung mobile broadband, low latency or URLLC, and the massive IoT. Yan. So, yun yung three types of network slices. But, kapag binili na yan ng operator, it can, it can further go into different slices pa, no? That can be customized by operator. Okay, so it can be used or can be customized pa. So each network slice has a segment of the RAN. So pwedeng magkakaiba ng frequency yan. Okay? Segment of the core, meron kang virtualized function or virtualized network function para dun sa iyong service. segment of the transport network, yung backhaul natin, and one of the numerous services, no? And life cycle management. Okay. So, anong ibig sabihin nun, sir? So, sa network slicing, for example, yung EMBB. Yan. So, meron tayong separate slice, no? So, meron kang run slice. So, sa run slice, um, it could be, for example, yung mga EMBB natin would be going to the millimeter wave. Yeah. So we can already do a network slice dun sa RAN. And then yung mga non-EMBB natin sa kabilang frequency. So meron na tayong slice. Sa transport naman, pwede natin siya bigyan ng QoS. And then this sa core, meron tayong network functions, different network functions, and MANO naman, no? Management and network orchestration. Okay? Ito naman yung ating network slice for V2X, no, vehicle to everything, and network slice for IoT. So ano kagandahan niyan, ano? For example, sa EDSA, no? So you are providing a network slice for V2X. Kunyari, meron na tayong V2X dito. Vehicle to everything. So pagka merong congestion do sa area, pwede natin siyang bigyan ng additional capacity, no? We can put a dedicated run slice for those vehicles during the peak hours. So for example, ano ba yung rush hour natin? From 6 ba? 6 to 8? 6 to 8 a.m. Pero after 8 a.m. mula, for example, 9 a.m. hanggang 12 p.m., wala nang ganong tao sa kalsada, right? May mga ganon. So, yung resource ko doon, pwede ko nang i-allocate sa ibang services, right? So, kaya ito yung gamit ng mga network functions na yan. You can configure the network functions as the network requirement, no? As per network requirement. So, kung wala nang masyadong gumagamit ng resource doon, I can assign it to a different slice. Yun ang kagandahan sa network slicing. Okay? So, you can guarantee yung QoS and then you can allocate, no, the network resource to another slice. And then when it comes to Open RAN, ganyan din ang mangyayari, no? So instead of the assigning it manually, so the use of artificial intelligence and machine learning using the RAN intelligent controller will do that function. Okay, so matatrace na nung ano yun, nung artificial intelligence, ano yung pattern, no, na kinakailangan do sa certain area. Na for example, dumadami yung tao on this specific period of time. So mag-a-assign siya, no, ng mga network functions diyan and then capacity requirement for those kind of in that area. And then kapag dumating na yung less congested na siya, so tatanggalin niya na yung resource, no? Pwede mo na siya i-delete dito. And then you can just configure on the other slices. Okay? So meron tayo dyan mga network function virtualization. Kaya kasama sa Asia Open Academy yung virtualization, okay, software-defined networking, and open flow. Kasi pagdating natin sa management and network orchestration, gagamitin natin yan, si network function virtualization. Okay? Ayan. So ito yung ating network slicing. So ano pa ang isang benefit ng network slicing? So aside from separating the different services, you can also make your architecture flexible. So matatandaan nyo pagdating ng Open RAN, pag-uusapan natin sa Open RAN, so yung baseband unit natin will be divided into centralized unit and a distributed unit. Dito papasok yung topics natin about cloud and edge computing. Okay, so makita niyo yung mga courses inside the Asia Open Academy are designed, no, to have ano ba tawag dito? Symbiotic ba 'yan? So para magano siya, no, support each other. So makita nyo, for example, sa EMBB slice. So okay, so this is the end-to-end illustration. So the core cloud, okay, so you have the cloud computing here. So all of these functionalities, including mobility, charging, session management, and access management, are located in the core cloud. And then you have this local buffering sa edge cloud. Nandito yung ating baseband unit. And then your radio unit is located sa G node B. And then andito yung ating UE. So you can get, well, in the target, 20 gigabit per second. Okay. Now, if your slice is all about IoT, massive IoT, so what you will do here is that yung hindi mo na kailangan i-cache yung local content mo, okay, sa edge cloud. You can put all your functionalities, major functionalities sa cloud, okay, because most of these are transmitting as a simple on-off or indicator or status, no? Hindi siya nangangailangan ng malaking data to transmit. So you have the radio on site, and then you have the BBU on the edge cloud, and then yung functionality na nasa core cloud. Okay? And then yung ating use case that is requiring a time sensitive, no, a very critical application like V2X, or for example remote surgery. So the charging is only applicable here sa core cloud. But the important functions are getting nearer, no, to our subscribers. Bakit? Para nga mas mabilis yung latency. Okay? The nearer the equipment sa ating mga subscribers, it also reduces yung latency. Okay? So makita nyo yung mga functionalities natin from the core cloud, nilipat natin sa edge cloud. Okay, so dito na papasok yung edge computing natin, of course, di ba? So low latency, nandiyan yung session management, V2X server, nandiyan yung BBU, mobility management, and access management. And then yung radio natin nandito. So you can get as much as lower than 5 millisecond latency. Okay, so this is how we are augmenting our architecture sa 5G. So it has become a flexible architecture depending on the type of use case or the network slice that we want to give to our subscribers. Okay?